Hello students. In the previous class, you have learnt about organic. What is organic compound? The organic compound usually made up of carbon, hydrogen, oxygen, nitrogen, sulfur, etc. In that, we have learnt about hydrocarbons. Hydrocarbons are the compounds made up of carbon and hydrogen only. So let us start a new chapter in organic, that is haloalkanes and haloarenes. As you remember, one of the remarkable property of the carbon atom is its unique capacity to form bond with other carbon atoms. This property is called as catenation power. Because of this reason only, the carbon atom can link with each other to form either linear chain or branch chain, or even it can form ring of different sizes. This is the basic thing for the carbon. It can form organic compound. So whenever you are dealing with an organic compound, you need to check the valency of carbon. It should be tetravalent. In this case, you can find that each carbon atom is bonded by 4 bonds. You can see each having 4 bonds. So whenever you are dealing with an organic compound, you want to check whether the structure is correct or not. You need to find it out whether it is each carbon atom is tetravalent, it is satisfied or not. Then only we can make sure the compound is correct. So in this case also you can find that each carbon atom is bonded and you can see all have 4 bond. So let us discuss the formation of haloalkanes and haloarenes from hydrocarbon. You are familiar with alkanes. Alkane having general formula CnH2n plus 2. Here we have taken one alkane, that is 3 carbon alkane, which is called as propane. So when one of the hydrogen atom from alkane is replaced by a halogen atom, which is represented by X, then it is called as haloalkane. Halo word relates to halogens. That means from alkane, when there is a replacement of hydrogen by an halo group or the halogen atom, then instead of saying alkane, we can call it as haloalkane. Similarly, from arene, arene is aromatic part of hydrocarbon like benzene. In benzene also, when one of the hydrogen atom is replaced by a halogen atom which is represented by X, then it is called as haloarene. Just check the name. Arene is converted into haloarene by the replacement of one of the hydrogen to a halogen atom. Now it is not called as a hydrocarbon because hydrocarbon means which consists of only carbon and hydrogen. But here when you check, it consists of carbon, hydrogen and halogen atom. Haloalkanes can also be called as alkyl halides. Similarly, haloarenes can also be called as aryl halides. Here, alkyl word related to the carbon chain, as in this figure, the 3 carbon and the hydrogen together, it forms a group which is called as alkyl group, and alkyl group is represented by letter R. So usually in the formula, that is in the general formula, we used to represent the alkyl group as R and halogen as represented as X. So usually we find some reactions in which general formula is written. In that case, instead of taking the carbon chain, we used to take R. So what is R? R is the alkyl group. Alkyl group means when from an alkane one hydrogen is removed, then that part is called as alkyl part. Here also, in this also, when we talk about this part, it is called as aryl part, which is represented by AR. So AR with bonded with X together called as aryl halide. So AR, the word is aryl, and for X it is halides. So how we can name the haloalkanes and haloarenes? It can also be named as alkyl halides and as well as aryl halides, where alkyl group is represented by capital R and aryl group is represented by AR. Here R can be any number of carbon chain, branch chain, or even the cyclic chain. Many halogen derivatives occur in nature and some of these are clinically useful. These class of compounds find a wide applications in the medicinal field, in the research area. So it is a quite important class of organic compound. So let us discuss the detail of these. As we discussed, these are also called as alkyl halides, where R represent an alkyl group, X represent a halogen atom. Similarly, in aryl halides, AR represent the aryl group and X represent the halogen atom. Alkyl group, which is represented by R, it can be one carbon group, that is methyl, two carbon group, that is ethyl, and three carbon propyl. Similarly, the alkyl group may be branched. It can be cyclic. How we find out an alkyl group? Instead of writing methyl group, we can write it as CH3. Instead of writing this, we can also write in short CH3. It can be written as C2H5. Ethyl group can be written as C2H5. Propyl, this is propyl group because 3 carbon. How we name this one? This is from propane. When H is removed, then it is called as propyl. It can be represented C3H7-. In all the alkyl group, it is necessary to keep a bond after writing the carbon and hydrogen. It shows that it is further added, because when you check the carbon number valency, each are satisfied now also. When you check this carbon 1, 2, 3, 4, it is satisfied. Let us check this carbon 1, 2, 3, 4, it is satisfied. So that means you need to keep a bond for each alkyl group. It shows that it is added. It is not a compound, it is a group, or we can say it is a part of the organic compound. It is not an organic compound, it is a part of organic compound that is represented by group, alkyl group. These alkyl group can be open chain, that means straight chain. As shown in the figure, it can be cyclic and even it can be branched. In the first case, let us check the number of carbon atom in this. As we have learned, it is in the form of bond line 1, 2, 3, 4, 5, 6. 6 carbon. Therefore, it is hexyl. Hexyl group. and there is no branching in this. In this 1, 2, 3, 4, 5. 5 carbon atoms are there, and all the 5 carbon atoms are in a cyclic form. Therefore, it is called a cyclo, and this is 5 carbon, therefore pent, cyclopentyl. Similarly, this is a branched because here 1, 2, 3, 4, 5 carbon atom, 5 carbon atom in a chain, and there is one branching at this carbon atom. So we can say that the alkyl group can be either straight chain, can be cyclic, and even it can be branched. In haloalkane, halo group, which is represented by X, it can be fluorine, chlorine, bromine, iodine. And while writing the formula, we use the symbols F, Cl, Br, I respectively. But when we are talking a group, instead of saying fluorine, we use the word fluoro, chloro, bromo, and even iodo, depending upon the type of halogen atom present in it. So, in this video, we have discussed about the basic concepts which is needed to discuss haloalkanes and haloarenes in detail. That is, how haloalkanes and haloarenes are formed due to the replacement of hydrogen from alkane and arene. And it is represented by R, X in haloalkane, and for haloarene, ARX. So in the next video, we will be discussing the details about haloalkanes and haloarenes. Thank you everyone.